Alright, this is the second video on projectile motion and position, velocity, and acceleration. A rock is thrown vertically upward from the surface of the moon at a velocity of 24 meters per second and reaches a height of s of t equals negative 0.8 t squared plus 24 t meters in t seconds. Find the rock's velocity and acceleration as a function of time. All right, so first thing, by now your first thought should be to take the derivative. So velocity is going to be the first derivative of position. Take the derivative here, I get negative 1.6 t plus 24. All right, now to find the acceleration, I'm going to have the second derivative. So we're just going to have negative 1.6. Now I don't see any units on that, but I see that the problem is talking about meters per second. You have to be paying attention to units. So what I'm going to put now, since this is acceleration, meters per second squared. So that's going to be our acceleration on the surface of the moon. Negative 1.6 meters per second squared. So you should notice that that's different from on Earth. Now, how long will it take the rock to reach its highest point? In the last video, we talked about its highest point is when the velocity equals 0, because the rock goes up, it has a positive velocity till it reaches its max height. At its max height at 0, then it starts coming back down. All right, so what I'm going to do is set v of t equal to 0 and solve. So my equation over here was negative 1.6 t plus 24 equals 0. Subtract 24 on both sides. Negative 1.6 t equals negative 24. Divide by 1.6 and you get 24 divided by 1.6. 15. And add your units on. So the rock reaches its max height at 15 seconds. Now, how high did the rock go? All right, well, we know at 15 seconds it reaches its max height. How high did it go? That means that I need to take 15 and plug it into my position function, because position is telling you how high the rock goes. So I have s of t equals negative 0.8 t squared plus 24t. Plug in 15, so I'm going to have s of 15 equals negative 0.8 times 15 squared plus 24 times 15. All right, let's work this out real quick. All right, 24 times 15. All right, so right here I got plus 360, and then 15 squared is 225 times negative 0.8. So I get negative 180 plus 360, and I get 180. Let's add on our units. Always be paying attention to units. For this problem, it's meters. All right, so the rock goes all the way up to 180 meters. Now, how long did it take the rock to reach half its maximum height? All right, well, the max height from part C is 180 meters. This means that half the max height is 90 meters. I want to know how long it's going to take to get to 90 meters. 90 is a position, it's how high we are. So I want to know when my position is equal to 90. So I'm going to take my position function, negative 0.8t, and I'm going to set it equal to 90. Sorry, I messed up there. That was not my position function. My position function is negative 0.8t squared plus 24t, and I set that equal to 90. All right, now from here I need to go ahead and solve. I'm going to divide both sides by negative 0.08. So let's do that real quick. All right, so that's going to give me all right, let's do 24 divided by 0.8. I get 30. T equals 90 divided by 0.8, 112.5. Alright, now from here, let's get everything on the same side. So I have t squared plus 30t plus 112.5 equals 0. Alright, rather than show all the steps out right now, you can't factor this, so I would either graph or put it in the graphing calculator. Or you could use the quadratic formula from back in Algebra 1 and Algebra 2. Alright, so on a separate sheet, I did the quadratic formula, and you get t equals 25.607, or t equals, let me check for a second, 4.393. Alright. Now, how long was the rock aloft? So aloft, how long was it in the air? Alright. So this means that I need to check. This means I need to check when my position was 0. So I'm going to take S of t and set it equal to 0. Alright, and solve. So S of t was negative 0.8 t squared plus 24t, and I set it equal to 0. I'm going to factor out a negative 0.8t, and I'm left with t minus 30, because if you divide 0.8 out of 24, you get 30. Alright, this means my two t values are t equals 0 or t equals 30. Alright, so this means that when my rock first was getting thrown, before it got thrown, the position or the time was 0, and then it gets to the ground at 30 seconds. So the rock is aloft for 30 seconds. Aloft, just another word for in the air. Rock is aloft for 30 seconds. All right. Find the rock's speed when hitting the surface of the moon. All right. So I know it's going to hit the surface from the last part at 30 seconds. All right. I know I'm asking for speed, which means I first have to look at velocity and then take the absolute value. So the velocity function we have was negative 1.6 t plus 24. I want to know the velocity when it's hitting the surface, so I'm going to plug in 30. All right. Let's go ahead and do that real quick. So I'm going to have here 1.6 times 30 So here I have negative 48 plus 24, and I get negative 24 meters per second. Now, it asks for speed, so I have to take the absolute value. Alright, so when the rock is hitting the ground, it's traveling at 24 meters per second. This concludes the second video on position, velocity, acceleration, and projectile motion.